Okay, so today we're going to look at graphing the inverse of a function. So our learning intention is to kind of work on the skills involved in graphing the inverse of a known function. We'll be successful if we know what the line creates, the inverse reflection. We'll be able to correctly sketch inverse functions, and we know the relationship between the original function and its inverse. Okay, so we're doing an example first. We're going to sketch y equals x and its inverse. So y equals x is that special line where the x value is the same for all y values. Okay, so technically if that was 1, 1, 2, 2, 3, 3, 4, 4, and so forth. So we get this wonderful line y equals x. Okay, now we've gone through how to do the inverse. So there's your original function, y equals x, and the rule of finding the inverse graphically is swapping the y and the x pronumerals. Yeah. So for example, if we had something like y equals x plus 2, to find the inverse, we would do this, and then make y the subject. So y equals x minus 2. Okay, so if we swapped this, we would get x, y. We get the same function. So that's really important. What it means is that all inverses reflect around this line, around the y equals x line. Okay. So the graph of the inverse is a reflection around the line y equals x. So I've kind of sketched it in these next examples. So my first example is that we want to sketch y equals x squared and its inverse. So this is basically a normal parabola. So 1, 1, 2, 4, and then 3, 8, minus 1, 2, and 4. So here is our normal parabola. And what we're going to do, so I'll draw that maybe in blue. So here's our normal parabola. And what we're going to do is we want to sketch the inverse. So we're going to reflect this parabola around this y-axis, y equals x line. So first we'll do y equals x squared is the original function. We're going to swap the pronumerals. So we get x equals y squared, and make y the subject. So we get y equals plus or minus the square root of x. Okay, so if we had a table of values, I'll just do a quick one here. So we've got x and y. So do 0, 1, 2, 3, and 4. Okay. Well, 4 is plus or minus 2. 1 would be plus or minus 1. 0 would be plus or, well, just 0. 2 would be plus or minus the square root of 2, and plus or minus the square root of 3. Okay. So if I was to do it, and we're going to do this in red. So we're going to start here at 0. We've got 1 and 1. And I'm going to do 4, 2, 3, 4. And that's 2 and 2. So what you can see is that we get this side parabola as it's reflecting around this axis. Yeah, so that origin stays the same. That's moving down to here. That's the 1 and 1. And the 2 and 4s are moving down to 4 and 2. They swap over. Next example, we're going to sketch y equals x cubed. So we have 0, we have 1, 2, we have 8. So 2, 4, 6, somewhere all the way up here. Yeah, sorry. A little bit of a curve. Goes up. Curve. Alright. So something that looks like that. Do that in blue. Okay, and we're going to rotate it again around the y equals x axis. So we'll convert it into, we'll find the inverse. So I'll swap it out. So we've got y equals x cubed. We'll swap the pronumerals around. So y equals plus or minus the square root, positive square root of 3. Yep. So if we do a table of values again, square root of 0 is still 0. The square root of 1 is 1. The cube root of x cube would be 8, would be 2. Okay. And obviously these will be all positive. Okay, so we have 0, we have 1, 2, 4, 6, 8 would be 2. And so we get, something that looks like that. And if I had -1, would still be -1. No, I can't. So it just starts at 0. Sorry, 0. Yep. Okay. Alright. Now, some important things. If we have an original function that passes the horizontal line test, such as y equals x cubed, then the function, the original function is 1 to 1. Okay. As an inverse is swapping the x and y values, then the original function passes the horizontal line test. The inverse will also create another function. So if it passes the horizontal line test as the original function, it will create an inverse function. Yeah. Where for every x value there is one y value. If the original function does not pass the horizontal line test, then the inverse result will produce a relation. So if we go back to here, these examples, the first example was y equals x as a straight line. So a straight line will always create an inverse function. So this parabola, this quadratic, is a function, but when we do the inverse, it becomes a relation. Yeah, that we have many to one. Yeah, many to one. But here we have a cubic, and it does create that kind of thing. Yeah, because you have a negative 8. Yeah. This is 1 to 1, which is still a function. And as its inverse is created, it creates another function. Yeah. So if it passes the horizontal line test, its inverse will also be a function. If a function does pass the horizontal line test, then the function is either always increasing or always decreasing. So for example, y equals x cubed is always increasing. And we call these monotonically increasing. It's constantly increasing. And if we had y, so here we go, that's always increasing, that's monotonic increasing. If you get y equals negative x cubed, that's monotonically decreasing. It's constantly decreasing. Concavity changes at the point of inflection, but it's monotonically decreasing. Okay, so we're going to practice some sketching the inverse of x squared minus 1. That's a parabola. I've got x minus 2 or cube, so I've got a cubic, and I've got x minus 3 square root, and that's a semicircle, or that's a a side parabola. So we're going to find its inverse. So once again, you do y equals x squared minus 1. We change the pronumerals around, and we're going to make y the subject. So we've got x plus 1 equals y squared. So y equals plus or minus x plus 1. Okay. So 0 plus 1 is 1. Square root is plus or minus 1. Plus or minus square root 2. Plus or minus square root 3. Plus or minus 4. Sorry, no. 3 plus 1 is 4. Plus or minus 2, sorry. And this is plus or minus square root 5. So if we were to draw it, we've got 0, 0 plus or minus 1. So we've got that plus and 1. And there. 1 is square root 2. So next one I'm going to do is 3, which is plus or minus 2. Okay. So if I had negative 1 plus 1 would be 0, it will be here. So we get this inverse. So this is the original function was a was a function, but as it did not pass the horizontal line test, it created a relation. Okay, here we have a cubic. It does pass the horizontal line test, so it will create a function. So we're going to go y equals x minus 2 cubed. Swap the pronumerals around. Okay, and so plus or minus the cube root of x, y minus 2, so y equals 2 plus or minus the cube root of x. Yep. Plotting some points. Okay, because we're going to reverse it around here. So we have the cube root of 0 is just 0, so that's going to be 2. Sorry, that's just plus. So 2 plus 1 is 3. So we'll do just these to like one decimal place. 2 plus the cube root of 2 is 3.3. 3.4 and 3.6. Okay, and obviously if we went up, the next one would be 8, which will give us 6. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. Okay, 0 is 2, 1 is 3, and get something like that. Obviously, so we have negative 1, would be 1. Something like that. Okay. All right. Example 3, we've got y equals x minus 3 all squared root. Swap the pronumerals around. Okay, that becomes x squared y minus 3. So we get y equals x squared plus 3. We know how to sketch this very easily. So we've got x squared plus 3, 1, 2, 3, and that's where we go. So we move everything up 1 unit. So 4 plus 3 is 7. Very high up. Okay. So we're just reflecting around this axis. So 2 units, 2 units. Okay.